record, and I want to switch my camera to this camera. Okay, today we're going to hit chapter 11. Chapter 11, some of you have had 162, and we've talked a little bit about these things called handling exceptions. Okay, an exception. So if I'm running a program and for some reason, and the big example is if I say, please enter a numerator and you put in 4, and I say, please enter a denominator 0, and I get ready and I say, okay, now I want you to divide 4 by 0. Your program just blows up, okay? Because you can't divide by 0. You know that brings all kinds of trouble into play, because if I said, ooh, we're allowed to divide by 0, you know, that's in our math world, we go, what is 0 times 1? Well, that's 0, right? What's 0 times 2? That's 0. You all agree to that, right? Nathan, you agree to that? Say yes. Nathan, say yes. Yes, okay. You're muted, but I saw your lips move. So by the transitive property, I can do this because they're equal to each other. And then in the world of B, if I was allowed to divide by 0, I'd be left with 1 equals 2. And that sort of destroys all of mathematics, because everything in math has to make sense. So that's just one example. And I know you've all seen this before, right? Don't be one of those days. It's a Monday fun day. So anyhow, we can't divide by 0. We can't open a file that doesn't exist. If we try to do that, we get into trouble. And when I mention a file not existing, that goes into that. You saw something like this a long time ago. Throws. What do we have to include? Throws.
IO exception.
Thank you. IO exception. Remember, folks, this is a participation sport. Okay. That throws IO exception has a little bit to deal with what we're doing today. Okay. So just kind of keep that in mind. But when one of these errors occurs, one of these exception errors, as we're going to call them, we have to figure out how to handle it. Okay. And what is this error? Well, when this error actually occurs, an object is created. Okay, so if an object is created, that means that object has to come from a class somewhere. So all of these classes are written to handle these exceptions. And we're going to take a look at all those classes in a little bit. So I have an exception that happens. When this exception happens, an actual object is created, which means, I start thinking of an object. What's an object? That's part of a class. We have all that going on. So when one of these exceptions occurs and the object is created, we throw that object. Okay. Now, where do we throw it? Well, that's going to be to something that's already predefined, or that could be something that we create. And what we're going to take a look at today is throwing it into exceptions that are already defined. Okay. So the first thing, well, you did a bunch of code listings, and we're going to first take a look at this awesome chart. Now, we're familiar with the idea of superclasses and subclasses. Okay. And this chart, and with these arrows, that goes back to our UML charts with a superclass and a subclass type of concept. So we have this guy right up here, the super de-duper class. It's always there. We never see it. We have a lot of things inherent from it. A subclass of objects is something called throwable. And as you can see by this chart, throwable has a subclass acceptance, has subclasses down here, has subclasses down here. And we're just going to take a look at a couple of them. If I come down and I get one of these objects thrown from the class error or below, it's bad. We can't mess with it. It's not a good thing. But ones we get start to fall down this category. And here's a class, IO exception. And remember, we had to do some special work when we were doing with files and make sure we had this IO exception available. We even have subclasses of IO exception, as you're going to see later. An end of file problem with a file. You know, these are more specific. A file not found type of problem, and so on. Here's a class called runtime exception. This is one where we get the ever popular Java, we don't like it, index out of bounds when dealing with an array. Some of you had C++. We didn't have anything like that going on. So think of the whole right now. We're going to break it down into parts, basically, and then come back to the whole. But we have this giant layout, giant chart of super and subclasses. Okay, so we took a look at that. Now, I want to get ready, and you know, you did your code listings, all but 3 of you. 3 folks didn't do code listings, so you don't have any idea what I'm talking about, plus you lost points for that. But how do I handle an exception? Well, what I'm going to do is I'm going to say, I think there might be a problem in this block of code. So I need to point out that block of code. And the way I do it is I make it a try block, which means I start with the word try, and I have starting and ending braces. If something bad happens in that try block, I go to this catch clause. And the catch clause is actually going to catch a variable, an object of a certain class. So this exception type is a class, and this is what would be the object name. It's in our parameter list, so we call it a parameter name. Code listing 11.2 takes a look at, why my camera on? Here we go. We're coming in. We got, let's see, we got the Java IO and, for the file not found exception, we need to, okay, I come in, I try, and now if a certain error is generated, and there could be different errors generated, and if I just happen to generate the error and it's a file not found exception, normally our program would just crash. But by putting it in a try block, it says, ooh, if there happens to be a file not found error, right, an exception is created, we can handle it with this catch block. There we go. With this catch block. So I'm coming in my program. If everything works hunky-dory, I do lines 25, 26, 27. I get to 29. I skip down and go to 35 and whatever follows. It'll skip the catch block. Now, if I come in here and a file is not found, what it'll do is kick me out of this block and it'll land me in a catch block. Now, the catch block that it lands in is the one that's the file not found exception. If there was another type of file problem, it wouldn't land in here. It only comes in here with the file not found exception. Once again, this is a class name, file not found exception. So this becomes a data type for an object which has a name E. Now that's a common little object name E that's put in there. Okay, it's an actual object. So if I had any kind of stuff going on with the constructor in that class file not found exception, or methods that are in file not found exception, then I can use any of those on the object E inside of here. But for now, I'm just saying get there and print out the message file not found. Now, what I want to do is I'm going to pause for a second, and I want you to Google, and somebody can share their screen, file not found exception class, so we can see what kind of methods and stuff that are predefined in the file not found exception. So I get ready to record. So now taking a look at that, that's telling me inside of here, I could have put E dot, that one method was called get message. And maybe some kind of message would appear or something. Okay. But again, this E is an object and it's something that I can use. All right, let's keep going. Retrieving data. All right, the next code listing was 11.3. Let's take a look at it. And bam, there it is. Just as I mentioned a moment ago, we have file not found exception E, we come in, and by our discovery, we noticed there was a method, and it was dot get message. So when I ran this, I came to line 29. If no error occurred, I jumped out and hit 35 and 36. If there was an error that occurred, I jumped down into the exception, not an error. There was an exception. I jumped down into line 32. And if you ran it, it did give a message if the file wasn't found. We typed in a bad name and it said, the file, blah, 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 the system cannot find the file specified. So that's part of what is in get name. Here's another type of error. Notice this time, instead of the file not found exception, I'm using a class that's already written. Like I said, this section, we're only talking about classes that are already written. But here's another one that's already written, number format exception. And if I went back to that chart, I can see runtime and so on. But here was the file not found. The other one is probably going to come under one of these other categories. Again, we mentioned a moment ago about throwables and object. So I come in, and this time it's a number format exception. What's that mean? I come in and I have a string, and I come in the try block, and I do number integer dot parse int. What would cause this to crash? Well, if the str was quote 63, this would be all good. But str is the string ABCDE, and I can't convert that to an integer. Program would crash because we have this number format error. But we're saying, wait a minute, if there is a number format error, I want to catch it. I want to handle it with this message, da 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 da, which is a nice message, a conversion error. The message would be for input string, da 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 da. So it captures that. So this is another class, a number format exception class. All right, that was code listing 11.3, code listing 11.4. Okay, next up. Well, we just saw what if I have, well, our programs are going to be bigger than what we just looked at. And what if I had several different types of exceptions I would like to handle? Well, I can have multiple things going on. I can have a try block that is that big. I'm doing files, I'm doing all kind of stuff. I'm doing division, and I might want to have several catch blocks. So as soon as an exception occurs, it's going to start searching for a try block. It's going to start at the top try block and go from there. Now, when it comes in, this first guy is going to catch file not found exceptions. Okay. The second one is going to catch any possible input mismatch exceptions. So this was file not found, that was up above. This was input mismatch exception. And what would an input mismatch exception be? Well, if I come up here in the file and I try to read in a double and it weren't no double, that would be an example of catching that. And as you can see, inside of the catch clause, I have a message, non-numeric data found in the file. Could have been a char, could have been a string, could have been something else. So I'm able to have multiple catch clauses. Questions?
Yeah, I have one actually.
Yes.
So just for like the sake of convention, is it best to, like, these are short examples, so they wrap the whole program pretty much in the try block and then put the catch blocks after, but like in a longer program, should we do that, or should we kind of put the try block where the error might actually occur? Does that make sense?
Yeah, the try block where the error might occur is more common.
Okay.
Good question. Other questions? Okay, taking a look at this next code listing. I believe this is one, again, you typed in. Sales report too. And again, a lot of you, I know Harrison was just saying about the code listings, but they're pretty good examples. And that's why we continue to use these Gaddis textbooks. But as you can see, we have, let's see, input IO for class and file not found exception, scanner, J option pane. Okay, all of that's good. I come down, yeah, as a lot of you have learned, there are some variables it's best to initialize, accumulators, counters, and so on. Get those bad boys to 0. I get ready and I come into my program and let's see what we have going on here. The more examples, the better off we are. While input file not equal to null. Okay, file name. What is that while input file not equal to null? Am I allowed to do that?
Input file is Boolean, isn't it?
Yeah, while it doesn't exist. Well, it's not Boolean, it's just while it doesn't exist. And again, this is slowly one of these brutal habits I'm trying to get you to form, and that is your documentation. If the open file method returned null, then the file was not found. Ask for a new file name. Oh, that makes kind of sense if I just read that. All right, so what do I come in here now? I'm going to take a file and I'm going to read it in. While it has a piece of data, I'm going to come into my try block. I'm going to convert it and do everything I need to do. If there's something goofy in the data file, which, you know, there could be typos when creating data files. If there's something goofy in there, instead of it crashing, I now take care of it and handle it. You notice that when I handle it, I come down and it now lets me go to the next line. Okay, where do I go after line 57? Don't say 58. Okay, I said it, 58. Where do I go after 58? Bueller?
You go back 30.
I hear a 38. So after this, yeah, I say, oh, what's that ending brace for? And all of a sudden I go, oh, this is part of my while loop. So even though I found bad data, I know there's bad data in there, I can display it and so forth. But if it is bad, display it, read a new number in, and stay up in that while loop. Again, the more different types of code you look at, more things that are tucked away in the back of your head. So if you had a data file with 6,000 pieces of data, and you know there might be typos, you could catch those typos, right? When I hit this and it's not happy, I jump down here and catch it, I handle it, and then I skip to the next one. It'll come back up to the while, and it'll land inside of this loop. Capiche? And again, this line is just to skip past the bad data. You notice it's reading it in as the next line because it's probably a character or a string or something. So this is needed to gobble up that bad line. Once it gobbles it up, then we come back up and read the next number. Comes in, if it's bad, it comes down, says, oh, it's bad, gobbles it up and moves to the next number. Okay? Now, there were try blocks to take care of that. Do you notice also in this program, we call a function open file. This is kind of almost nice to have tucked away. And inside of here, I have a try block. I read it in. And if it's bad, this is where that null comes in. Once I executed this, I have a variable named scan that is going to be the returning value for this open file. So when I come back up here to open the file, this is where that null comes in. Questions? Here again, I'm calling open file. Multiple try blocks, multiple catch blocks, lots of different locations. So basically we handled exceptions. Now we're going to take a look at some more and take a look at this chart. I'm on page 717. We know object was the superclass of all. It had a subclass throwable, and we saw some methods that were in throwable. Okay, it has a subclass called exception. Exception has a subclass runtime exception, which has a subclass illegal argument, which has a subclass number format exception. Okay, these are all inheriting the properties of all of the parents. So this guy has the most, a little bit more than that, which has a little bit more than that, and so on. Why am I showing you that chart? Well, if I take a look at this block of code and I say, okay, try number integer dot parse int, there could be two exceptions generated here. Okay, one is called an illegal argument exception. One is called a number format exception. Now, number format exception never happens because illegal argument exception will eat up both of them. And if we look over here, if I get an exception, it's going to go to the parent first. So if there's a number format exception, that's going to get eaten up in here. And I will never get to these type of exceptions. So when I list my catch clauses, I need to put them in because they're read from top to bottom. Will it fit into this? Yes or no. Will it fit into this? So in order to do this, I need to put the lower ones first so I can get the more specific and then work my way up to my superclass. So here, the superclass coming first will gobble it up. I'll never get to the subclass. Down here, I list the subclass first, so it'll handle that one. What's not caught in there will get caught in here. Make sense? So the order does in fact matter. The finally clause. I have try, I have catch, and I have finally. Okay. What the finally clause does is after the try or after the catch, this guy gets executed no matter what. No matter if I'm coming out of here, no matter if I'm coming out of here. Whichever one I come out of, I automatically go to the final. Okay. Why do I have a finally clause? Because something like this could become really important if your file is not closed. And this goes back to, I wrote a program back in 1989 for the Lancaster Lebanon Cross Country League. And I don't know if you know anything about how cross country is scored, but every person gets a number, 1, 2, 3, 4 in their place of order. Okay. And if you have 7, 8 people on your team, everybody gets a number, but only your first 5 numbers count for your team score. The rest are just displacers for other teams. So, you know, if your team was 1, 2, 6, 7, and 8, and the next team was after that, but you had people finish before their top 5, you know, they get displaced down. And then you have teams that didn't have 5 people that finished. Well, I had to write a program for them. They asked me to write it, and I did it. And everything was perfect. And then it started to crash. And I couldn't figure out why it was crashing. Because as I would save the times and the numbers in the order of finishing, I wasn't closing my file. So luckily I discovered this with test data. But by not closing with files, the integrity of the data in the files. So my lesson learned, always, always, always make sure you can close your file. to keep that integrity. So that's a finally clause. It's one that gets executed no matter what after the try block. Questions? Okay, I mentioned a little while ago something called stack trace. And we come in and we have a program and we have a method called my method. Inside of here, it calls a method called produce error, and produce error comes over here and we have a string and I say char at 3. And right away, a lot of you are going to wait, 0, 1, 2. You can't do 3. That's an index out of bounds error. It blows up. Well, we've seen examples where when it blows up, I have output messages that I never really cared to look at. But if I take a look at this one, we see that there's this stack trace that goes on. It calls my method, it calls produce error, then I get exception in main, string index out of bounds. Okay, that's about all we would see. When we were looking at our output, we would see that and move on. But if you take a look, it happened at the char at, and we'll look at what's highlighted. It was in the method produce error, which was called by the method my method, which was called in the main. So you start to look at this error message, and all of a sudden you may be saying, well, that error message sure makes sense. Never really looked at it before. But this is a possible error message you could get. Not unrealistic, but that's what we would have. All right, what do we have next? We have, just a nice simple example. Here's a try block. And I just need to know if an error occurs. I don't need to really do a lot when I handle it in my catch clause, but I know I'm working with files and doing some other things. But this example simply shows a catch clause that will catch either a file not found exception or an input mismatch exception. And it'll store it in EX. Now, again, that's a dummy name. I'm not really using it. And all that happens here is I display an error. Questions? Questions. Now, finally, there are some nasty errors. We have checked and unchecked exceptions. Yeah, I have a lot highlighted here. Unchecked exceptions are those that inherit from the error class. Yeah, we don't want to mess around with any of those. Okay, so it's just an extra note of what's going on, of something bad that could really happen. Okay, questions? Questions? I am going to stop there.